video is on finding the area of a regular polygon. Today we're going to focus on finding the area of an equilateral triangle and a regular hexagon. So remember that regular means all angles and all sides congruent. So we're going to focus on basically a hexagon and an equilateral triangle today, but we'll take this a step further here in a couple days to all regular polygons. So it can have any number of sides. So remember, a hexagon has 6 sides. Of course, an equilateral triangle has 3, and then I have an example here of a decagon, which we're not going to do one of those today, but eventually we will get to those. So basically the note says that you can circumscribe a circle about any regular polygon. And the area of a regular polygon is related to the distance from the center of the polygon to any side. So before we get started here, we need to define a couple of things. So in this first example here, I have a regular hexagon inscribed inside of a circle. So all of these sides are congruent, and all of these angles here are congruent. From the center of my polygon, which is the same as my center of my circle, out to a vertex of my polygon is called the radius, just like the radius of my circle. So this is my radius. From the center of my polygon, perpendicular down to a side is called the apothem. So that is a new word for us. So this right here is the apothem, and the apothem is equal to the perpendicular distance from the center of a polygon. It has to be a regular polygon, to a side. So each one of these regular polygons will have both a radius and an apothem. So right here, from my center of my polygon out to the vertex is my radius. And then from the center of my polygon perpendicular to a side is my apothem. And same thing over here. From the center of my polygon to a vertex is my radius. And then perpendicular to a side, right here, is my apothem. Okay, so we're going to use both the apothem and the radius to help us find the area of any regular polygon. So a new formula for us today is the area of a regular polygon formula, and it is equal to 1/2 the apothem times the perimeter. So we will just abbreviate this. A equals 1/2, and we'll use lowercase a for apothem and lowercase p for perimeter. And we can do this for any regular polygon. So for my first example, I'm going to use a regular hexagon. So the first thing that we need to know in this regular hexagon is we need to know what all of the angles measure. So this one you might have memorized, but if you remember a while back, we had the formula n minus 2 times 180 divided by n. And this will allow us to find the angle of any regular polygon. So in this case, n is 6. So I'm going to substitute 6 in here. So 6 minus 2 times 180 divided by 6 will be 4 times 180 divided by 6, or 720 divided by 6 will give you 120 degrees. So each one of these angles is 120 degrees. Now, what I'm going to give you is I'm going to give you the radius of this regular hexagon. So the radius of this regular hexagon, let's say, is 8 inches. Now, when you draw on those radii, and I'm going to draw on one over here also, what happens is this bisects these angles. So this angle now is cut in half, and this makes 60 degrees here and 60 degrees here. I'm also going to draw in my apothem. So my apothem goes from the center of my polygon perpendicular down, and what now happens is I have created two right triangles, and specifically two 30, 60, 90 right triangles. So this angle up here is 30, and this angle here is 30. So I can now, knowing my radius, which is my hypotenuse of my 30, 60, 90 triangle, I can now find my short leg and my long leg. So remember, the short leg times 2 equals your hypotenuse. So in this case, short times 2 equals 8. So my short leg is 4. So that makes my segment right here 4 units. And my short times square root of 3 equals long. So 4 times square root of 3 equals long. So that makes my apothem be 4 radical 3. Well, because these two triangles are congruent, when I drop this apothem down, it bisected this side, and that would be true for any regular polygon. So this is also 4. So the side of my hexagon is now 8. And so this is 8, all the way around my hexagon. So now I can find the area of my hexagon. I'm going to sub into the formula. Area equals 1/2 apothem times perimeter. And I'm going to have 1/2 times my apothem, which is 4 radical 3, times my perimeter. Well, if I have a side length of 8 for 6 sides, 8 times 6 is 48. So I'm going to have 48 times 4 radical 3 times 1/2. So if I take half of 4 is going to become 2 radical 3 times 48. And then 48 times 2 is going to be 96 radical 3. And my label is going to be, let's see, my label I believe was inches. So my label is going to be inches squared. So that is the area of my regular hexagon. Okay, so this will work for any regular polygon. So if I have an equilateral triangle, remember in an equilateral triangle, all of these sides are congruent, and 180 divided by 3, you should hopefully know that all of these angles are 60. The formula that we used before would also work. This time, I'm going to draw in my radius and my apothem. Again, my apothem will bisect this side, and my radii bisect these angles. So this angle's 30, this angle's 30. So that makes this be 60 up here. So again, I have a 30, 60, 90 triangle. 30, 60, 90 triangles will only show up in a hexagon and an equilateral triangle. If we have other shapes, we'll have different types of triangles then. So in this problem, again, I'm going to give you the radius. So to make this easy, let's make the radius here 6 feet. So again, I know the hypotenuse, so I can find the short leg. So the short leg is half of my hypotenuse. So my short leg would be 6 divided by 2, which would be 3 feet. That would equal my short leg. Remember, my short leg is always opposite my 30-degree angle. So in this case, my apothem is my 3 feet. My long leg is my short times the square root of 3. So my long leg here, which is opposite the 60-degree angle, is now 3 times the square root of 3. So this is also 3 times the square root of 3. So my whole bottom length is 6 radical 3, because 3 radical 3 plus 3 radical 3 is 6 radical 3. So the area of my regular polygon is 1/2 apothem times perimeter. So 1/2 times 3 times my perimeter is going to be 6 radical 3 times 3, because there's 3 sides. So 18 radical 3 for my perimeter times 3 times 1/2. So this time it's easier to take half of 18. So half of 18 radical 3 times 3. So half of 18 is 9 radical 3 times 3 is 27 radical 3 feet squared is my area. Now, remember, another formula that we used earlier in the year for our equilateral triangle is 1/4 square root of 3s squared. So I could also use this formula. So 1/4 square root of 3 times 6 radical 3 squared. So if I square 6 radical 3, that becomes 36 times 3. Okay, and 36 times 3 is 108. And then if I take that times 1/4 times the square root of 3, well, 1/4 of 108 is 27. So my answer becomes 27 square root of 3 feet squared. And so I get the same answer no matter how I do this.